Assalamualaikum warahmatullahi wabarakatuh, or good afternoon, or good evening, everyone. It is nice to meet you all. Thank you for being here, and thanks to the committees of MIMSE, University of Mataram. Let me introduce myself. I am Dr. Salman, lecturer in the Department of Mechanical Engineering, Faculty of Engineering, University of Mataram, Indonesia. Let me share with you the topic, the utilization of SEC or silicon carbide to improve the impact strength of aluminum scrap and its microstructure with sintering method. My goal is to explain the effect of adjoining the silicon carbide or SEC to the aluminum scrap or AL scrap on impact strength and microstructure using powder metallurgy or sintering method. As a short overview of the topic, I'm going to divide the session into 3 sessions. The first session is introduction of aluminum scrap and SEC, and then the second session is we would like to talk about the method to produce composite AL SEC material, and then the third session is we are welcoming all to discuss the result of impact test of the material AL-SEC. The basic property of pure aluminum or AL is it has good testability but quite poor mechanical properties. So to improve the mechanical properties of the metal, it is necessary to strengthen the metal by adding hard materials such as ceramics. The types of ceramic materials commonly used in this case are aluminum oxide or Al2O3, SEC, TEC, and zirconium dioxide or ZrO2. Among the ceramic types, the hardest is SEC. SEC compounds are easy to bind and do not cause oxidation of aluminum metal. Meanwhile, oxide like ceramic materials such as Al2O3 and ZrO2 are also relatively hard and strong, but the weakness is it is difficult to bond with aluminum metal. So, in addition, the presence of oxygen or oxide groups has the potential for oxidation to occur in all metal composites. Indonesia, we know, has a larger potential for bauxite production. Bauxite is a source of aluminum. Meanwhile, SEC ceramics are not directly available in nature. Therefore, SEC powder can be made from a carbothermal mixing process. The advantage of this powder metallurgy method is it is easier to control the constituent materials to obtain mechanical and physical properties according to the desired variation. So, the research that will be, or a study that will be carried out in this time is to improve the impact softness and silicon carbide powder to the aluminum scrap from was the aluminum soft production. The addition process is carried out by sintering method or powder metallurgy because the two materials are quite complicated when done with the casting process. So the method in this study we had it in some parts. First, molding process, and then the second part is sintering process, and then the third is impact test, and then the fourth microstructure test, and then the next part is ANOVA analysis, and then the next part is the data observation or discussion. So the method, the first method is molding. There are three molds that we are used in this study. 3 square molds with the same size, with dimension 57 millimeter multiply 55 millimeter multiply 100 millimeter. And then the material or mold uses an iron plate with thickness 8 millimeter for the pressing, and then 3 millimeter for the wall or the wall of the mold. The next step is sintering. Sintering process is, a process of compacting of a collection of powders at higher temperatures near their melting point until change into the microstructure. The material from mold was inserted with or along with its mold into the oven heater with a temperature of heater is 500 Celsius degree. After that, they were cooled on high environment until the temperature matches the room temperature. The mixed material is aluminum scrap with silicon carbide. Which has fitted beforehand with a particle size 200 mesh. The pressing of materials is carried out with Hunta instrument machine with a larger pressure used is 150 kilonewton. The next step is impact test. The aim of the impact test is to measure the softness or ability of material to absorb energy before breaking. Impact testing is used to determine the tendency of material to become brittle or ductile based on its softness. There are two methods that have become the standard for this impact test. They are Charpy method and Method method. Both methods have specifications. The impact was done by pendulum that was hitting to the object or the energy absorbed by object until it breaks. The formula can be seen here. The absorbed energy is E is equal to mass of pendulum multiply gravity acceleration multiply with arm length, and then cos beta and minus cos alpha. Beta and alpha is the angle of the pendulum position. And then after that, we have another formula of impact strength. The next step is microstructure test. Microstructure test has a purpose. It is to observe the level of gradation of the atomic molecule particles. With a microscope instrument, we can see more clearly later that the microstructure of the surface of the specimen after experiencing impact can be studied. This leads to the identification of structure of metal by clarifying the grain boundaries of the metal. To observe the microstructure of the specimen after impact test, the specimen is mounted with resin to facilitate the polishing process. After that, the surface was rubbed and with a velvet cloth with the addition of a sufficient autosol. So it is the preparation beforehand the microstructure testing. The next is we can see the result of impact test here. According to the variation of SEC content, it affects the result of the impact toughness as well. So in this graph, I mean, we can see the relationship between impact value or absorbed impact with the percentage of SEC content. The SEC ingredient or percentage of SEC affects the result of the impact toughness and absorbed energy. We can see here that impact energy is relatively low due to the condensation process and the less than optimal sintering temperature. So we can see also here the differences of three variations of SEC ingredients. For 0% of SEC, we can see clearly here the difference is between the fracture of SEC with 20% ingredient. And then also the microstructure appearance. Beneath, we can see here the distinction among the three variations of the SEC ingredients. By ANOVA analysis, we would like to validate the experiment by using a theoretical analysis. In this case, we use ANOVA one way. We have the formula that if F count less than S stable, it means each zero is accepted. It means also no significant effect between each variation of the experiment. Oppositely, if F count more than S stable, each one is accepted, is not accepted, and so there is significant effect between each variation of the experiment. Unfortunately, in this experiment, we have F count less than S stable, so we don't know exactly what is the reason behind this result of ANOVA analysis. However, we can discuss later if we have the time. And then as the conclusion that the addition of SEC to aluminum scrap affects the impact toughness according to the experimental experience. And at low SEC percentage or below 20% of SEC, there are still uncrystallizated aluminum scrap powder particles that causes the incomplete bonding. Therefore, the value of impact strength is also low. So thank you very much for the attention. I'm welcoming the further discussion for this topic.